Section 2.2 Conditional Statements. Our goals for today are to be able to recognize conditional statements and their parts. We're also going to write converses, inverses, and contrapositives of conditionals. So a conditional statement is an if-then statement. And the notation for if-then statements is P, the arrow, followed by Q. And it's read, if P, then Q. The hypothesis is part P of the statement, which follows the word if. The conclusion is part Q, which follows the word then. Okay, let's take a look at a more concrete example. We want to identify the hypothesis and conclusion of this conditional statement. So the statement is, if an animal is a robin, then the animal is a bird. So, an animal is a robin is our hypothesis, or part P of the statement. Our conclusion is then the animal is a bird. That's also referred to as part Q. We could also look at this as a Venn diagram where the hypothesis, the animal is a robin, then the animal is a bird. So robin would be one subset of all of the possibilities. So now we're going to look at a statement and write it as a conditional. So the first step is we have to identify the hypothesis and the conclusion. So vertical angles share a vertex. Vertical angles is going to be my hypothesis. My conclusion is going to be share a vertex. So how am I going to write that? So to write it, I'm going to say if two angles are vertical, comma, then they share a vertex. So the only word that I've added is two, because how many angles do you need to have vertical angles? You need at least two. So if two angles are vertical, then they share a vertex. Now just because a conditional is written doesn't mean that it's true. So it's just like anything else that anyone says, you've got to find the truth value. So if we want to show that a conditional is false, all you have to do is find one counterexample where the hypothesis is true and the conclusion is false. So just because we've written a conditional doesn't mean that it's true. So let's take a look at a couple of examples of finding the truth value. So if a woman is Hungarian, then she is European. So Hungary is a European nation, so this one is true. If a number is divisible by 3, then it is odd. So this one is false. Why is it false? Because 12 is divisible by 3 and it is even. Now, as we move on, we're going to need to make a negation of the statement. And that just means to say the opposite. So if I have the sky is blue, what would be the negation of that statement? The sky is not blue. So the negation of the sky is blue is the sky is not blue. So the symbol for that would be not P. Okay, so now we're going to write the conditional, converse, inverse, and contrapositive of one statement. So these are going to be uncomfortable because you're going to be writing stuff. On some of these, you're going to go, wait, that's not true. And remember, just because we write it doesn't mean that we're saying that it's true. So conditional, we're going to use the given, hypothesis, and conclusion. So if the measure of angle A is equal to 15 degrees, then angle A is acute. And that's going to be symbolized by if P, then Q. Now when we talk about the converse, we're going to switch the order. We're going to exchange the hypothesis and the conclusion. So we're actually going to be writing if Q, then P. So for this one, we would write if angle A is acute, then the measure of angle A is equal to 15 degrees. So now we're talking about the inverse. Whenever we're writing the inverse of a conditional, we're going to negate both the hypothesis and the conclusion. So we're really going to be saying not P, then not Q. So we would write that as if the measure of angle A is not equal to 15 degrees, then angle A is not acute. So again, we would write if the measure of angle A is not equal to 15 degrees, then angle A is not acute. So last but not least is the contrapositive. So for this one, we're going to negate both the hypothesis and conclusion of the converse. So we're going to say if not Q, then not P. So for this one, it would be if angle A is not acute, then the measure of angle A is not equal to 15 degrees. So we negated the converse example. So if angle A is not acute, then the measure of angle A is not equal to 15 degrees. So one thing that's really important to remember is every conditional has three related conditional statements: the converse, the inverse, and the contrapositive. Now let's take a look at those same four statements that we just made right here. I've put them down into this chart. So what we're going to do is we're going to evaluate their truth value. So if the measure of angle A is equal to 15 degrees, then angle A is acute. So this one is true. The converse statement: if angle A is acute, then the measure of angle A is 15 degrees. I'm going to say that this one is false. Why is it false? Well, it doesn't have to be 15 degrees. An acute angle is anything less than 90 and greater than 0. So we could have angle A is 45 degrees. The inverse statement: if the measure of angle A is not equal to 15 degrees, then the measure of angle A is not acute. So this one is false as well, because 15 degrees isn't the only acute angle. So again, the angle could be 45 degrees like we put here. the contrapositive. If angle A is not acute, then the measure of angle A is not equal to 15 degrees. That is true. So equivalent statements will always have the same truth value. A conditional and its contrapositive. So the conditional and its contrapositive are equivalent statements. They are either both true or both false. Okay, so now we're going to find the converse, inverse, and contrapositive of this conditional. If the figure is a square, then the figure is a quadrilateral. So the first thing we have to do is identify the hypothesis and the conclusion. So the hypothesis is the figure is a square. The conclusion is the figure is a quadrilateral. So I want you to pause and write down the converse and its truth value. And if the truth value is false, I'd like a counterexample. The converse of the conditional statement is, if the figure is a quadrilateral, then the figure is a square. The truth value of this is false, because if I have a rectangle, it is a quadrilateral, but it is not a square. Okay, now I'd like for you to do the same thing with the inverse. So the inverse would be, if the figure is not a square, then the figure is not a quadrilateral. So this one would be false as well, because quadrilaterals are things other than squares, and my counterexample could be a rectangle again. Now I'd like for you to write the contrapositive. Remember, it's going to be if not Q, then not P. So go ahead and pause and see if you get the same thing I do. So you should have gotten, if the figure is not a quadrilateral, then the figure is not a square. And what's the truth value of this one? Okay, so this one is true, because if it's not a quadrilateral, it can't be a square, because all squares are quadrilaterals. I also want you to notice that our conditional statement, if the figure is a square, then the figure is a quadrilateral, and our contrapositive statement are both true. So remember that a conditional and its contrapositive are equivalent statements. They are either both true or both false.